This is a PDP-1144. It's the last non-LSI PDP-11 that was ever built. After this, they really started focusing on miniaturization using large-scale integration to ultimately get down to something like this. This is a PDP-1173 CPU card meant for a Q-bus chassis, and you can see it is minuscule in comparison to the 8-ish cards that make up the CPU in this massive Unibus chassis that's sitting right next to me. But I think this 1144 is pretty special. First of all, it's the last of its kind, the last non-LSI PDP-11, but also that huge Unibus chassis and massive backplane and wild power supply offer a lot of customization and expandability options that you don't get on the micro PDPs. And I want to lean on that to turn this 1144 into a supercomputer. And everybody who's intimately familiar with the 1144 just immediately scoffed at that statement. But I think it's actually doable. But I also think I'm going to need your help to do it. So in order to explain what all of that is, I got to pull the table out and get some show and tell stuff going on here. So I'm going to get all that set up, and you guys can sit back and watch the opening credits. Let's talk very briefly about supercomputing here for a second, because ultimately this episode is supposed to be about the 1144 here, and here we are with all sorts of strange junk on the table. But if I understand it correctly, and I could very much so be wrong here because I'm just now starting to dip my toes into this realm of computing. But traditional computers like the 1144 here are very good at sequential operations. If I want to add two numbers together, I load operand A into a register, I load operand B into a register, I add those two registers together, I get the result in an accumulator, and I copy that result to someplace in memory. But if I want to do addition on two sets of numbers for like 30 different sets, that's going to take a long time because it's like 6 operations per addition and you got to do that 30 times. So in that situation, you need something called an array processor. An array processor allows you to load up, for example, 30 different sets of numbers and then perform an addition on all 30 different sets simultaneously and get 30 different results back. This allows you to do hardcore number crunching at a lightning pace compared to a traditional machine like this. But you're essentially doing, again, as I understand it, you're doing the same operation on all sets of numbers. You're either doing an addition for everything or a subtraction for everything or a multiplication for everything or something like that. If you want to go one step further, you have to get into something called MIMD, or multiple instruction, multiple data. You load up your 30 different sets of numbers, and then you can do addition on this one, multiplication on this one, subtraction on this one. You can do different instructions on your multiple sets of data and then get an array of answers back. So that allows you to do even more hardcore number crunching at an even faster pace. So whenever you see a picture of a supercomputer from the 1970s, look in the background. There's just a phalanx of wicked mini computers that are purely there to feed the Cray 1 data. It's really hard to keep that machine fed because it's doing massive amounts of number crunching simultaneously. So a supercomputer is actually easier to think of as an add-on or a co-processor for a host machine. And in the 1970s and up into the 1980s, there was a company called Floating Point Systems that was building array processor add-ons for different machines. Notably, the AP120B and the FPS100 were two machines that they built, nice array processor add-ons, and they were used on the GE CT8800 and 9800 CT scanner to do the number crunching required to generate an image of somebody's brain. So this is like, essentially people had a Data General Nova with a supercomputer attached to it to do the processing for CT. And well, if we look at the stuff that I have here in front of me, I happen to have a board set from an FPS 100. I also have the front panel here. These were saved from a machine that was destined for the scrappers, and as sad as that is, it's something that happened many years ago, so there's no real reason to dwell on it. We have what we have. And this, being an FPS 100, is an array processor add-on. Not only that, I have something that's pretty rare, I think, and that is this card right here. This is a PDP-11 interface card for the FPS 100. And I think this card is cross-compatible between an FPS 100 and an AP120B. So if we had a functioning FPS 100 or AP120B, we could get this connected up to this 1144 here and have a working array processor. But what is this massive chassis over here? Well, this is an FPS 3000. And if you saw this chassis on eBay recently for a ludicrous amount of money, don't worry, I did not pay that much for it. I threw out a insultingly low offer at about 1/20th of what they were asking for it, and they took it. So hallelujah, we got this epic machine here. But what is an FPS 3000? Actually, we don't really know. We think it's related to the FPS 5000, which we found just a tiny slice of information on. And I believe that this is a MIMD, multiple instruction, multiple data add-on for an FPS 100, which is an array processor add-on for our PDP-1144 here. So with this admittedly very incomplete combo right here, we could build a pretty gnarly supercomputer. And when I say gnarly, I actually have some information here about the FPS 5000. So the host system can be whatever it is, and it's talking to an array processor, and they list an AP120B or FPS 100 here, and they're saying 8 to 12 megaflops. But if we go down below that, we can see the XP32 CPU, which this has in it, is doing like 18 megaflops. Now, I don't know if this is additive or not, but if we can get all of this working on an 1144, we could be looking at between 20 and 30 megaflops out of a PDP-11. And like, honestly, that is so ludicrously fast that I don't think the 1144 can feed data to this combination quick enough to keep it running at full tilt. But we're gonna try. Now, the reason that this is all just sitting here like this and I'm not actively working on it, it's because we just don't know hardly anything about this. I have been working very closely with some pretty legendary people like BitSavers, the BitSavers. It's been an absolute joy working with him. But also a good friend of mine, Coley's been in the middle of this. We got somebody named Bob that's been hanging out on the Discord who actually wrote software for an FPS 100 on an old CT scanner back in the 80s. We have an amazing team put together, but the information just isn't there. I'm willing to build a new backplane and power supply from scratch for this FPS 100 board set, but in order to do that, I need schematics. And we have found some, but they're not the right schematics and they aren't covering everything. And just information is so thin out there. And so this is where I'm gonna put out a call to you guys. If anybody watching this knows anything at all and has any documentation about any floating point systems hardware, get in touch and let us know, because we want to get this stuff working. We want to see a PDP-11 supercomputer running a ton of FPS systems. I'm totally in love with this machine, but right now we're kind of at an impasse. We can't really proceed much further. And you know what? I'm going to go one step further. If anybody out there has access to any FPS hardware that they're willing to part ways with, reach out. Maybe we can work out a deal. Like I said, I'm totally in love with this company and I want to see this stuff come up. So the more hardware we can get here to work on, I think the better chance we have of actually getting into real deal supercomputing with a PDP-11. But all of that is requiring the PDP-11 to work, and this PDP-11 has been a battle to get up and going. This 1144 has been fighting me, and it was all pretty much in the power supply. So let's clear all of this supercomputing junk off the table here. We'll get the PDP-11 fired up and make sure that we're in the same state where we left off in the previous episode, which was a couple of months ago. And then we're gonna try and get much further along. Okay, this is a classic case of ran when parked. It's pretty much set up exactly how it was in the previous episode. I've got the full CPU in it, plus the floating point unit, plus the business instruction set cards. So that's fully populated. We have a 1 megabyte memory card, 2 grant continuity cards here at the back, and a terminator. This is a pretty minimal setup for a PDP-11 44. We just want to see it come on here and say console version 3.40C and halt because it's looking to boot into a drive that's not there. So let's flip the power switch and see what happens. Yeah, there we go. Console version 3.40C halted at 165.714. Unfortunately, my DC on light down here is now blinking, so my power supply is now unhappy again. All right, we seem to be mostly working. The flickering DC on light solved itself, actually, while I was trying to get the camera set up to film it, so I didn't even really get good footage of it. And I reckon that the more that we run that thing, the more stable it's going to become. So now that we are where we left off last time, what's next? Well, first things first, one of the fans in there is dead, and I've got a replacement for it. So we need to get the machine out of the cage so I can pull the fans out and replace that fan. After that, I want to start stress testing the CPU because ODT is not going to be pushing that CPU very hard. I also want to expand the memory out. Right now there is a 1 megabyte card in there, and I've got 3 more of that very same type of 1 megabyte memory card. So I can push this all the way up to 4 megabytes, which is the max that the 1144 can handle. So once we've done that, I need to find some way to test that memory. And the best way to do that is to load up like a diagnostic program like I think XXDP. There's so many unknowns with this system that if we're trying to troubleshoot bringing up a floppy drive and a floppy controller at the same time as troubleshoot some kind of potential fault in the CPU or the memory, we're just going to run around in circles. So we need something that's known good that can emulate a bunch of other things and allow us to test individual parts of the machine as we bring it up incrementally. And we're going to do that with this thing right here. This is a Unibone. It is not my personal Unibone. It is on loan from a good friend, Mark. And it has a full-on BeagleBone FPGA on it, and it can like emulate pretty much anything. And we can use this to essentially stress test the machine. Very cool piece of kit, but way beyond my capabilities. So I'm gonna hop on a phone call with my buddy Mark, and we are going to try to get this plugged into the 1144 and see where we can go from there. First things first though, let's fix that bad fan. To get to it, I'm gonna rotate the entire chassis up onto its side, which isn't easy because this thing is a beast. But once it's on its side, I can undo the 2 screws that hold the fan assembly in place. Then I just pull the assembly up enough to access the Molex plug. After I wiggle that loose, the entire fan assembly pulls straight up and out. I'll then unplug all the connectors to the individual fans, and then I'll pull all 3 fans out of the assembly. It's just 4 screws per fan, and while 2 of these do work, I want to make sure that everything going back in is free and clean and spins well. Mark hooked me up with some spare fans, and even though they're in new boxes, they are actually genuine deck fans out of a proper BA11 chassis. Once I've selected the 3 best fans, I'll pop them back in and cinch them down nice and tight. Then I can just drop the fan assembly back in place, plug in the Molex power connector, and away we go. With the fans taken care of, I hopped on a call with my good buddy Mark. He was wonderfully patient with me, walking me through the ins and outs of the Unibone. We had it hooked up to the local network so I could SSH into it, and with Mark's help, familiarize myself with the file structure. The BeagleBone is essentially running Linux, and if one were familiar with navigating Linux, it'd be a cinch to use, but I'm still a Linux noob, so a lot of this is very foreign to me. Still, Mark is an excellent teacher, and we worked our way through the files, learning which ones we can use and how to use them. And armed with this newfound knowledge, I think it's time to get the Unibone plugged into the 1144. All right, we've got the Unibone in the PDP-1144 here. I've got the grant continuity in front of it. Everything should be set up correctly for that, but I have no idea what I'm doing. So I've got my good friend Mark here on call. Mark, say hi to everybody.
Hello, everybody.
So he's here to give me emotional support and technical support because I am completely lost, but I'm learning rapidly because Mark's an excellent teacher. So we've got the Unibone in there. It should power up. And what we're expecting to happen is that when I flip the primary switch here, the 1144 should print something here like it's always done. And then the Unibone takes about a minute to boot up. But once the Unibone has booted up, we've got it plugged into this WY60 terminal over here, which I got from AJ at Forgotten Machines. So AJ, if you're watching, this thing's getting a lot of great use. But it's talking through that, so we should be able to control the Unibone on the WICE terminal and change out the disk images that we're using. So once that's fully booted up, we'll tell it to load up an XXDP image. That should reset the 1144 and then boot into an XXDP image, hopefully, which would be the first time that the 1144s run like proper real deal software. So I don't know, all we got left to do is flip the switch and see what happens. So I'll flip the power switch here. That's coming up. We did get the 3.40C. I got a CP didn't start. I don't know. The PDP-11 may be unhappy. It might be happy. But the only real way to find out is to wait for the Unibone to come up over here. So that's going to take about a minute. All right, so the Unibone came up. It took longer than I was expecting, but the CP didn't start over here is making me nervous. And if I look at the DC on light, it's flashing now. I don't know, maybe the extra power draw is making the power supply unhappy. So that might require some other problems, but we're at least going to try and move forward and see what happens here. So, Mark, what do I type on the Unibone here to load up an image?
Okay. /XXDP _ DL0 _DL1 _shared.sh.
All right. We'll hit return on that.
So right now it's busy connecting the two RO2 disk drives with XXDP on it and the two scratch drives. Now hit a return, and you've got the prompt from the Unibone.
No, it's still just sitting here with a blinking cursor on a blank screen.
Okay.
I can type, but it doesn't do anything. It doesn't go anywhere. Man, troubleshooting old computers is, first of all, hard, but also like 95% information gathering. And that's what yesterday ended up being mostly. We did make some like real deal legitimate progress and see some interesting things out of this, which I'm going to show you in a bit, but I think we got to solve some other problems that we discovered yesterday first to kind of eliminate some flaky behavior. And one of the first things that we discovered was that it's like super inconsistent. Some things work, some things don't, and we can't find a reason why. And ultimately, I think it's going to come down to that flashing DC on light that we keep seeing. Sometimes it flashes, sometimes it doesn't. So that tells me that we're probably sitting right on the bitter edge of what is considered an acceptable voltage level for one of the voltage rails. If we have a lower voltage rail, that's going to be causing a problem. So we got to solve the voltage rail problem, get stable voltage, and I think a lot of other things will start cleaning up. And we're going to check that using this card right here that Mark also hooked me up with. It is a MPG and bus grant continuity card, but it has little headers up here and 3 little gauges on the top here that are voltmeters. So we can plug this in and see what the voltage rails are at the bus. To test this, I'm going to remove the Unibone because it takes like a minute to boot fully into Linux, and I want a power cycle a little faster than that. With the Unibone out, I'm just going to slot in the new MPG bus grant continuity card with the little voltmeters on top of it. And once it's in, I'll flip the lights off in the room, so hopefully we can see this a little better. And let's flip the power on. Look at that. I saw it go as low as 4.67, and right now it's sitting at 4.68. The DC on light is flashing. That's too low. Wow. All right, so from left to right here, 4.68 is supposed to be our plus 5 volt rail. 15.1 is our negative 15 volt rail, and that's totally fine. That's perfect. 14.7 is our plus 15 volt rail. And actually, I think 14.7 is probably going to be fine on the plus 15. But this 4.68 volts here, man, that is too low. Now, out of curiosity, I moved it to the second backplane, which is not in use right now, but I just wanted to see if the voltage level on that backplane looked different. And look at that, 5.34 volts, 5.33 volts. That's totally fine. But our negative 15 volts is at negative 14.8, also totally fine. But our plus 15 volts is like non-existent. We don't even have enough to kick the voltmeter off. That is not okay. Looks like it's time to hoist this big beast out of the rack one more time. Remember folks, if your computer isn't heavy enough to murder you, can you really call it computing? Once it's on the bench, I'll tilt it up on its side, then remove the 4 screws holding the bottom panel on. And with that out of the way, we have nice and clean access to both the backplane and the power supply. I've been doing a bit of poking around on the bottom here, and I can't really see why this backplane is getting like 4.7 volts and this backplane is getting 5.3 volts. The 5 volts for both of those backplanes is coming from a bus bar. You can see right here, this bus bar goes here, 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 and here. And that's feeding the plus 5 volts into here as well as into here. We have good connection, and if I measure between this bus bar and the backplane, I'm measuring 0.0 ohms. So the only thing I can think of is that these like massive flat cables here may not have good connection to the bus bar itself. So I think I'm gonna pull these off and maybe give them a little bit of a sand to clean them up, and maybe then we can get a cleaner connection going on. The main 5 volt and ground supply to the backplane is through these wild flat ribbon style connector things. They bolt to the bus bars via clamping plates and lock nuts. After removing the nuts, I can get a better look at these things, and yeah, there is a bit of corrosion on these. That could be causing our issue. I'll take a Scotch pad and go over each connection to clean it up as best as I can. Then I'll do the same for the clamping plates as well. We want these as clean as possible because this thing has to move 120 amps through these cables, which is a hilariously large amount. Okay, I think that's a cleaner connection on the back. Let's flip the power on and see if the voltage levels have changed here. Yeah, look at that. 5.29, negative 14.8, and plus 14.9. I would say that we've solved our voltage level issue. That is perfect, exactly what I want to see. Now that the power supply seems a lot more stable and the CPU seems a lot happier, let's take this thing for a bit of a test drive. And we're going to do that with XXDP, which is like a diagnostics program for like pretty much every single PDP-11 that's ever been made. So we need to load that up on the Unibone. So I've got the Unibone prompt up here on the Weiss terminal. And I've already typed this in, so I think if I just hit the up arrow, yeah, there we go, /XXDP _ DL0 DL1 shared.sh. If I hit return on this, that should load the XXDP image into an emulated RL drive. So here we go. Yeah, that's loading right up. It's very, very verbose. There's a lot of information going on here. But some of the interesting things that we can see is that when it starts to make its emulated RL drive, it actually emulates the spin up of the RL drive. You can see that right here, RL drive spin up speed. What a crazy way to do it, but hopefully it seems to work pretty well. So it should have loaded up the bootstrap, so we can double check that by doing an E10010. This is an examine, and yeah, we've got 012700. That should be the bootstrap. So if I do a start S10010, it should, oh, I've got the halt switch switched. There we go. There we go, nice. Booting up XXDP-XM extended monitor. It detects 124 kilowords of memory. I guess this is functional. Okay, so let's run an actual test here, and I've got a little list here that shows what tests we can actually run. We'll just do a CPU and extended instruction set test, and that's going to be a run kkAAB0.bic. And if I hit enter on this, there we go. That, I think according to the XXDP documentation, that's all it should say. That means that it ran the CPU and extended instruction test completely, finished it, and it's on multiple passes now. That's good. That means that our CPU is working. So I'll halt the system here. This is a problem with XXDP that I don't know how to get past. I have to reload the bootloader every single time I run a test. So on the main terminal, I just do an M space LL. It reloads the bootloader. If I come back over here and examine 10010, I should have the bootloader in there. Now I can do a start 10010, hit return, and that should get us back up into XXDP. Now, off camera, I have run every single 1144 CPU test, and they all pass. So the CPU is healthy. But one thing that I haven't run is a memory test. And I looked that up this morning, and I think it's a test that starts with Z. So if I do a dir Z star dot star here, it should list, boy, that's a lot. Boy, that's a lot. Okay, there's a lot of tests that start with Z. Let's see here. The memory one should be ZMSP, I think. So as soon as this finishes its directory listing, we'll try again looking for that specific file. There we go. All right, we'll do a dir ZMSP star dot star. There it is, ZMSPCO. Okay, so we'll do a run here, ZMSPC0.BIC. Hit return on that. This should be a memory test that should be testing that 1 megabyte memory card. Unfortunately, I don't understand what any of this means. I don't know if that means that it's good or bad, but it's running at least. Mim type P CSR map. I don't know. It's, whoa, all right, we're getting stuff. 16 kiloword banks, errors 0. I guess that's a good news. I imagine that the memory test is going to take a while to run, but so far there haven't been any drastic errors, which is pretty fantastic news. So if this memory test passes, and I have already tested all of the CPU tests, that means that pretty much every PDP-11 card that we have in this chassis is fully working, which is fantastic. But I'm gonna let this run for a little bit just to see how it goes. All right, so there's one more thing that I want to test out here, and that is actually booting into an operating system of some kind, and we're going to use RT11 for that. So if I hit Q on the Unibone here, that exits us down to the root level again, and then I'll load up a different file here, ./RT11 version 5.5 FBDU0_34. We'll go ahead and hit return on this. It's going to load up the RT11 now, but it's not going to load it up as an RL drive. It's going to load it up as an MSCP drive, a mass storage something protocol drive. It allows the images to essentially be a lot bigger, and that should be loaded up. And just like before, we'll double check with E10000. That's where the bootstrap for RT11, this image should start at. 12700, that's correct. So we'll go S10000. I'll hit return. It's going to say halted because I still have the halt switch flipped. Move it over to boot. Yeah, there we go. RT11. But we can go one step further. We can do a boot RT11 xm.sys. This is a different version of RT11 that supports much wider memory. And it looks like we're fully into that as well. So I'll do a show all here, and I'll be quick on the hold screen button. There we go, RT11 XM version 05.05, booted from DU0, 22-bit addressing is on. And if we scroll down a little further here, we get some information about the system. PDP-1144 processor, 1024 kilobytes of memory, FP11 hardware floating point unit, extended instruction set, commercial instruction set, memory managed unit, ECC memory, cache memory. This PDP-11 is fully decked out from the CPU perspective, and it's working. RT11 fully booted on this PDP-11. How awesome is that? That's really, really cool. There you have it. The 1144 is feeling pretty good now that we've got that power supply issue sorted. And interestingly, the power supply was totally fine. It was just the connection between the supply and the backplane. With that fixed, this thing seems to be really stable. And we were able to get it into XXDP, and I ran every single test that XXDP has for the 1144 CPU, and it passed every single one with flying colors, except for the commercial instruction set test. I haven't run that one yet because it didn't start with a K and I didn't know what the number for it was. But I'll do that later. I'm confident it'll be fine. This 1144 is a beast, man. It's just sitting here chugging right along. The only thing that's been giving me grief is the power supply. But you can see that, I mean, it's pretty definitive that things are working really well because we're into RT11. If I hit the whole screen button here, it's currently running and doing stuff. That's awesome. So I think we're slated to start making the next step towards getting this 1144 fully featured and then starting to take the steps towards getting it and turning it into a supercomputer. And the next step is to get some kind of storage on it. And that's going to be this Fujitsu Eagle down here. I've been really excited about this drive, and it's time to start taking the steps towards this. That's what we're going to explore in the next episode. We're going to try and get a controller card for the Eagle in there, and then hopefully get maybe a version of RSX 11 on there, because I really do like RSX 11, and I really want to learn more about how to use it. So plenty more PDP-11 stuff to come this year. I hope you guys like big mini computers, and I hope you like supercomputers, because we're doing a lot of that. So I want to thank you all so much for watching, and I want to especially thank Mark for all the help, and I hope to see you all in the next episode.